Alright, welcome back to Geometry 11.3 and 11.4. We're looking at the area of regular polygons and circles. So first, the area of a circle. This isn't necessarily new to you. The area of a circle is pi r squared. Now, however, if I take a sector of a circle, okay, let's look at this circle here. If I want to find only this area up here, well, if I know that the radius, let's say the radius is 4, I can find the area of the whole circle by doing pi times 4 squared. So that's 16 pi for the area of the entire circle. But I only want this segment here. Well, I can see this is a fourth of the circle, so I could do this times 1/4. Well, if I didn't know that this is a fourth, if I was just given this is 90 degrees, how do I find the fourth? Well, a fourth with 90 degrees, that's 90 out of the 360. So that's my fraction of the circle. The angle out of 360 times 16 pi, and that gives me 4 pi for the area of this part of the circle, or I can multiply that 4 times 3.14, and that's approximately 12.56 or 12.57, depending on how many digits of pi you use. Alright, so our general rule is x over 360 times pi r squared for the area of a sector. Okay, if we want to use that, here we have a pizza, and it has a diameter of 12 inches and cut into 8 congruent slices. What's the area of one slice? Okay, so we know the area is x over 360 times pi r squared, or if you want to solve it this way around, we have pi times 6 being, pay attention, the diameter is 12. Okay, that one tends to trick us. And then 360 divided by 8 to figure out what that angle is right here, the central angle. We have to divide by 8 pieces. Okay, that gives us 45. And then multiply, cross multiply to solve. Divide by 360. And we have approximately 14.14 inches squared. Alright, 11.4. Area of regular polygons and composite figures. First, a few terms here. An apothem is a segment, I would say a perpendicular segment, drawn from the center of a regular polygon to a side of the polygon. The center of a regular polygon is also the center of its circumscribed circle. So this is what that means. We have our regular polygon, circumscribed circle. The center of that circle is also the center of the regular polygon. The radius of a regular polygon is also the radius of its circumscribed circle. And then the central angle of a regular polygon has its vertex at the center of the polygon, and its sides pass through consecutive vertices. And that looks like this. So there's the center, consecutive vertices, so from here to there. Okay, so there we have the central angle. Alright, the area of a regular n-gon, so however many sides it has with side lengths s, is 1/2 the product of the apothem and the perimeter. So here n means how many sides it has times the side length. So the side length times how many sides it has gives us the perimeter based on this triangle right here. Alright, a regular pentagon has 5 congruent central angles. If we want to find the area of this right here, we have a central angle of 360 divided by 5, because we have 5 triangles in here. Okay, so we're going to divide 360 by 5, gives us 72 degrees. Okay, now we just want one of these, and we can use the Pythagorean theorem. Okay, so we're going to take this triangle, one of those 5, and we know this is 72, so half of that is 36, and we know this is 10. Now we're going to go back to a little bit of SOHCAHTOA action here, and we're going to use those ratios to find SR and PS. Okay, so sine, remember SOHCAHTOA, sine opposite hypotenuse. Opposite of this angle that we know, we have SR to hypotenuse. That gives us a length here of 10 sine 36. So we multiplied by 10 on each side, and we were left with the length of the opposite. Same thing we can do for cosine. To find PS, multiply by 10. So PS is 10 cosine 36. Okay, now, if we want to find the perimeter of the entire pentagon, we'll take SR, double it to find QR, and so that's 20, so we're doing this times 2. So then we get 20 sine 36. Okay, and then, since we have 5 total sides, to find the perimeter, we take this times 5. Times 5, and that gives me 100 sine 36 for the perimeter all the way around. Okay, if you didn't catch that, if that went over your head, pause here, read through, or rewind. Alright, so we want to find the area. Now we just found the perimeter. Okay, and you could go back and say, well, we'll find the area of this triangle and then multiply by 5. You can do that too, or you find the perimeter and then you get the entire area. Alright, so we know the apothem, A, was 10 cosine 36, and the perimeter all the way around is 100 sine 36. And type that into your calculator, you get approximately 237.8 inches squared. Alright, now one last thing, composite figures. And we looked at this the other day too. This is nothing but splitting this up into its individual shapes and adding those together. So we'll find the area of this rectangle, the semicircle, and the triangle. So the rectangle is just 4 times 7. A semicircle, 180 degrees out of 360 is just a half a circle. So we do pi r squared divided by 2. And then for this triangle, we don't know the height. We know the base, 4, but we don't know the height, or the other way around. Okay, so if you know the lengths of A and C, subtract their squares and you'll get the square of B. Oh, and then square root it. There's nothing to it. So there we go. We got this side, 4.1. And that gives us an area, 1/2 base times height. 4 times 4.1. It's approximately 28 plus 8 pi plus 8.2. And that is 61.3 feet. So just adding each of these segments together. And that's finding the area of composite figures. Ladies and gentlemen, that's all the fun we're going to have today. See you in the next lesson.